friends, welcome to my YouTube channel Echo Aftab. In my today's class, we will be understanding about how to make use of the concept of matrices and determinants in solving linear equations. So, let us start with an example so that you will come to know how we are making use of the different concepts that we have studied in our matrices and determinants to solve our linear equations. So, let us start with an example. Let us say we are having three linear equations such as 4 x1 plus x2 minus 5 x3. This is equal to 8. The next equation is minus 2 x1 plus 3 x2 plus x3 is equal to 12. And the third equation is 3 x1 plus it is minus x2 plus 4 x3 and this is equal to 5. Now, we are having three equations with us. So, we can say these three equations can be represented in different ways. So, first thing is here x1, x2 and x3 can be written as x, y, z, or else it can also be written as a, b, c, and all these things can be any of our economic variables. If I say this x1, x2, x3, it can be represented as goods. So, it is something like in market 1, 4 units of apple, 1 unit of mango and 5 units of oranges, and this is the income, that is constant 8. So, how you are going to divide your income? So, here it can be 4 apples plus 1 orange minus 5 units of let us say mango, and this is your income. So, this is how we can read this particular equation. So, this is for the first market, this is for the second market, and this is for the third market. The system of matrices and determinants is used in order to find out what is the value of x1, what is the value of x2 and what is the value of x3, and that is what is called as making use of matrices and determinants in solving linear equations. Apart from economics, the usage of matrices and determinants is very varied, but we will limit ourselves only to understand how matrices and determinants are used to understand or to solve the system of linear equations. So, with this friends, we will go ahead. Now, I will try to put this thing in a form of a matrix. So, I will say this is a matrix A where I am taking all the coefficients 4, 1, minus 5, minus 2, 3 and 1, and at last from the third equation 3, minus 1, 4. So, this is our matrix A, 4, 1, minus 5, minus 2, 3, 1, 3, minus 1, 4. Then the next matrix I will write it as x matrix which is equal to x1, x2 and x3. This is our second matrix, and the last matrix I would like to call it as B, and that is equal to 8, 12, 5. So this is the way. So if you see it, I can say A multiplied by x is equal to B. So this A is our coefficient matrix, this x is our variable matrix, and this B is our constant matrix. Now what we need to do over here? So here you need to find out what is this x, what is the value of x1, x2 and x3. So to find out this particular x, I can rewrite this entire equation as x is equal to, as this A matrix comes on the right side, it becomes inverse, A inverse into B. And now our next part is to find out what is A inverse. As you know, A inverse, this is inverse of A. So how to calculate A inverse? A inverse is equal to 1 upon determinant of A multiplied by adjoint of A. The first step is now to find out determinant of A, and once you find out determinant of A, then you need to find out adjoint of A. And what is adjoint of A? Adjoint of A is nothing but it is the transpose of cofactor matrix. It is the transpose of cofactor matrix. So after finding out the determinant of A, then we need to find out the cofactor matrix and then transpose the cofactor matrix, and what you get at the end, we need to make use of that particular thing here as A inverse, and we need to multiply it by our constant matrix. So this is what we are going to do now. So now we will find determinant of A. So as you know, determinant of A, we can find it out by taking the elements of the first row and the minus of that particular element. So here we will take the first element 4 and we will try to find out its minus. So 3 into 4, 3 multiplied by 4 minus 1 into 1. Similarly, we will take the next element, and that is 1, that is minus 1. So this minus is coming in the calculation of matrices. So it is given. So here 1 is our value 1 and its minus are minus 2 into 4 minus 1 into 3, and the last element is minus 5 plus minus 5 into -5 into -2 into -1 minus 3 into 3. So, you can see here what I have done is this 4 is here, this 1 is here, and this -5 is here. So, this is how. And what are the minors of 4? 3, 1, -1, 4. So, 3 multiplied by 4 is here, minus -1 into 1 is here. So, this is what, this is the way we try to find out. So, now next what we get over here is this is equal to 4 in the bracket 3 4s are 12 minus -1 into 1 is -1, minus into minus is plus. So, this becomes +1, and here it is -1 multiplied by -2 into 4 is -8, -1 into 3 is -3. So, this becomes, friends, -8 -3, and at the end plus into minus is -5, and inside the bracket -2 into -1 is 2 -9. So, after further solving this thing, what we get is 4 into 13 -1 into -11 -5 into -7. So, after further solving it, we will be getting 13 into 4, and that is 52, -1 into -11, that is +11, and -5 into -7, that is +35. At the end, when I add up all these things together, 52 plus 11 plus 35, I get 98. So, friends, what I have got over here is determinant of A is equal to 98. So, in order to find out inverse of the matrix, the first thing that I got is 1 upon 98. Now, my next job is to find out what is adjoint of A. To find adjoint of A, you need to first transpose the cofactor matrix. Now, we need to first find out what is the cofactor matrix, and then we need to transpose the cofactor matrix to find out what is the adjoint of the matrix. So, the same matrix which is over here, we need to find the cofactor matrix of A. So, cofactor matrix of A, C is equal to, I will take the minus of all the elements in the matrix A. For this, you can refer my previous video where I told you how to find out the adjoint. So this is the minor of the first element 4 minus this is the minor of the second element 1 this is the minor of the third element in the row minus 5. In the same way, we need to take the minus of all the remaining elements. I am taking the minor of element 4, and here we can see this is our element 4, 4, 1, minus 2, 3. So this becomes our cofactor matrix. Now once we have got this thing, our next step is to solve it. So how to solve it? As we had found out at the time of determinants, just we need to cross multiply this. 3 into 4, 12, minus 1 into 1. So this is what we need to do. So for simplicity, I will do it over here. 3 into 4 minus 1 into 1, then comes minus 2 into 4 minus 1 into 3, then comes minus 2 into minus 1 minus 3 into 3. Similarly, and lastly 4 into 3 minus 1 into minus 2. So the moment we solve it, what we are going to get is this will be equal to 3 into 4, 12, minus 1 into 1 minus 1, minus into minus plus. So this becomes plus 1, and here minus is outside. Minus 2 into 4 is minus 8, minus 1 into 3, this is minus 3. So 8, so minus 2 into 4 minus 8 minus 3. So this is as it is. Then comes minus 2 into minus 1, 2, minus 9, and here it is 12 plus minus into minus 2 plus 2. So when we simplify this thing, what we get is we can see it over here, C is equal to 12 plus 1, 13, minus 8 minus 3 is minus 11, minus into minus is plus 11, 2 minus 9 is 7, and this is minus 4 plus 1. So you can see this is minus over here. So minus 4 plus 1 is 1. Next, 16 plus 15 is 31, and next minus 4 minus 3 is minus 7, minus into minus is plus 7. So 2 minus 9 is minus 7. Then next is 1 plus 15 is 16, minus 6 into minus is 6, and 12 plus 2 is 14. So what we got over here is our cofactor matrix. We need to transpose our cofactor matrix. And when we transpose this cofactor matrix, what we get is adjoint of matrix A, and that is just inverse the rows and columns. So this becomes 13, 1, 16, 11, 31, 6, minus 7, 7, 14. So here we have got our adjoint of A. Inverse of A is equal to 1 upon determinant of A multiplied by adjoint of A. So here A inverse is equal to 1 divided by 98 multiplied by adjoint of A, and that is, so this thing we can make it more simple by dividing all the elements of adjoint of A with the determinant. So this can be written as 13 upon 98, 1 upon 98, 16 upon 98, and so on, 11 upon 98, 7 upon 98, and 14 upon 98. So this is our inverse of A. So here you can see we have come to the last part. As we saw, to find out the variables x, we need A inverse matrix, and we are having the constant matrix as B. So what we need to do is just multiply the A inverse matrix, this is A inverse matrix, with our B matrix. So once you multiply this thing, you will get 13 into 8, 104 by 98, 1 into 12, 12 by 98, 16 into 5, 80 by 98. So similarly, here what I have done is I have simplified this particular fraction. It was actually 7 by 98. If you see 7 by 98, so if you simplify it, 7 ones are 7, 7 14s are 98. So this is what I have done over here. So after simplification, you can see we are having minus 8 by 14, 12 by 14, and 5 by 7. So further what we need to do is we need to add up these things, and once we add up these things, what we will be getting is the last part, and that is 104 plus 12 plus 80, that is 196 divided by 98. Here 88 plus 372 plus 30 is 490 divided by 98, and lastly plus 12 minus 8 plus 5, that is 14 divided by 14. So this is what we have got at the end. So you can see by further simplifying it, what we are going to get is 196 by 8 is 2, 490 by 98 is 5, and the last part 14 divided by 14 is 1. So this is what we have got. So if I say x is equal to 251, it means our x1 is equal to 2, x2 is equal to 5, and x3 is equal to 1. So here in the initial equation we can see the proof of it. You can see the proof of it. For that particular proof, let us take one equation. So I will take the first equation, 4x1 plus x2 plus minus 5x3 is equal to 8. So just by substituting the values, 4 into 2 plus 5 minus 5 into 1. So what we get is 4 2s are 8 plus 5 minus 5. So plus 5 and minus 5 will get cancelled, and what we get is 8. So we can see how matrices and determinants help us to find out what is the values of the unknown variables in a system of linear equations. So with this, friends, we end our class on solving linear equations using matrices and determinants.